Hey everyone, in this video we'll be looking at the second part of Chapter 9 of Dive into Python. The last bit, it's not too long, but the part 1 video was getting a little bit long, so I decided to break it out into two. So for this one, we're going to be talking about Unicode. Unicode is a system used to represent characters from the world's different languages. When Python parses data from XML, all the data is stored in memory as Unicode. Now, before Unicode, there were separate character encoding systems for each language, each using the same numbers from 0 to 255. Some languages, like Japanese, have so many characters that they required multiple byte character sets, which made exchanging documents very difficult. You'd need to store external information like which encoding method the author of the document was using to write. To solve these problems, Unicode represents each character as a 2-byte number from 0 to 65,535. Each 2-byte number represents a unique character used at least once in at least one of the world's languages. There's exactly one number per character and exactly one character per number. Unicode data is never ambiguous. There is still the matter of many legacy encoding systems, however. 7-bit ASCII, for example, which stores English characters as numbers ranging from 0 to 127. ASCII, also known as ASCII. English has a very simple alphabet, so it can be completely expressed in 7-bit ASCII. Western European languages like French, Spanish, and German all use an encoding system called ISO 8859-1, also called Latin 1, which uses the 7-bit ASCII characters for the numbers 0 through 127, but then extends into the 128 to 255 range for characters like N with a tilde over it and U with the umlauts. Unicode uses the same characters as 7-bit ASCII for 0 through 127, and the same characters as ISO 8859-1 for 128 through 255, and then extends from there into characters for other languages where the remaining numbers, 256 through 65,535. When dealing with Unicode, you may need to convert the data back into one of these legacy encoding systems. For instance, to integrate with some of the other computer systems which expect its data in a specific 1-byte encoding scheme, or to print it to a non-Unicode aware terminal. To save a string as a Unicode format, just add the character U before the starting quote of the string. So open a Python terminal and type this, in particular this U open quote. This is a string that we'll save as a Unicode Python object, end quote. See how we're adding that U in front of it to create a Unicode string. Whenever we attempt to print a string, Python will try to convert it to its default encoding, which is usually ASCII. It means you can store Unicode characters, but to print them on screen, you need to convert them into an old legacy encoding system. Now, let's talk about 6.py in the example 3 folder. We're going to write the Spanish N with a tilde over it. The Unicode character for the tilde N is 0xF1 in hexadecimal, 241 in decimal, which you can type like this, /x F1, right there. Hexadecimal is a number system with base 16. To print the character with correct encoding, we can set the encoding to string and then print that. Encode converts a Unicode object to a string object, and then decode converts a string object to a Unicode object. Always encode from Unicode to bytes. In this direction, you get to choose the encoding. For example, you can see here UTF-8, and it will encode these Chinese characters as this string, and when you print it, it will know. It will reinterpret it the right way to come out like that. The other way is to decode from bytes to Unicode. In this direction, you have to know what the encoding is. So you can see here, here's our long string, and when you have it print that, it comes out properly. You can also set the default encoding for the print in Python, but this is highly discouraged. And Python is usually smart enough to know offhand what you are trying to accomplish. If you want to look at 7.py, that will show you how to do set default encoding, but like I said, don't do it. Also note that in line 1 of 7.py, up here where it says that, if you're going to store a non-ASCII string within Python code, you need to specify the encoding of each individual .py file by putting that encoding declaration at the top of each file. Since we are storing lots of non-ASCII strings in 7.py, we have to specify that. For XML files, we can set the encoding like this, where it's basically a left angle bracket XML version, and then you give the version number, and then encoding equals, and then in double quotes, whatever you want it to be. Kind of a similar format to this, just with different syntax. Now we are going to parse XML with non-ASCII characters. See example 3.xml in 8.py of the example 3 folder. Here, this is how the encoding is set in XML. Sometimes traversing XML documents by stepping through each node can be tedious. No doubt, no doubt. You may be fine going deep into XML nodes, but there is a shortcut to find something in this tree. This is the command getElementsByTagName. This method search for all descendants, direct children, children's children, etc., of a particular element type name. 4.xml from the example 4 folder shows a simple XML file with a grammar node as the root node and 2 direct ref children, bit and byte. And you can see that here. Bit is either 0 or 1, and byte has 8 bits. First, the first ref child has 2 p children, and the second ref child has 1 p child. Now take a look at 9.py from the example folder. The output of this program is this. I'll show you those side by side. So running this through the Python interpreter gives you this output. Take a close look at line 3 in 9.py, the getElementsByTagName. This is giving us a list of all the nodes with the name ref. Since we have 2 ref tags in 4.xml, we get a list of 2 DOM elements. Printing DOM elements from the list with 2xml, the command 2xml, we get XML from those nodes. That's good, but we can actually do better. We can directly search the p tag, see 10.py from the example 4 folder, which is this one. And the output of that, which you can see here. See, it has all the tags and their inner XML. In this last section, we'll be using 4.xml from the example 4 folder, and it would be good practice to open a Python shell for this topic. XML elements can have 1 or more attributes, and it is incredibly simple to access them once you have parsed an XML document. XML documents have attributes, and Python objects also have attributes. When we parse an XML document, we get 2 types of Python objects. One which represents the piece of XML, and the other type of Python objects representing their XML attributes. So here's the Python code, and here's the output. You can see that, like I said, in 9.py and 4.xml. Next up is talking about the attributes of elements or nodes. Each element object has an attribute called attributes, which is a named node map object, or in simple words, an object that acts like a Python dictionary. Now that we know this named node map is similar to a dictionary, you can use Python's dictionary operations and attributes on this object. We are using Python's dictionary methods here. We can even access individual elements by storing references of these attributes. Before moving on to the next chapter, you should now know how to parse XML documents using Minidom, searching through the parse document, and accessing arbitrary element attributes and element children, as well as organizing complex libraries into packages and converting Unicode strings to different character encodings. So that's about all I have for this video. I hope it was helpful, and I'll see you all in the next one.